304 miles per hour. The fastest street-legal tire ever made. But this isn't about the car. It stars here, a pile of rubber.
Inside the Michelin factory,
Where rubber becomes legend.
Two brothers, Edouard, the engineer, André, the businessman. They inherited a failing rubber company and saw opportunity.
One day, a cyclist arrived with a damaged tire. It was glued to the wheel. It took hours to repair.
Edouard looked at that tire and asked a simple question. What if we could remove it?
In 1891, Michelin patented the first removable pneumatic tire. A cyclist named Charles Ter. By 1895, they dared to put pneumatic tires on automobiles. The world laughed, then watched.
In 1898, they created something on a figure made of tires. They called him.
The company grew. By 1906, they had factories in Italy, England, America. But they weren't finished innovating.
1946, the radial tire. It would take decades for the world to understand this was the future.
In a radial tire, steel belts run perpendicular to the direction of travel. This single change improved everything. In 1963, they built Ledoux, the most advanced tire testing center on Earth, still operational today. Today, 69 factories, 18 countries, 132,000 employees.
But the heart remains in Clermont-Ferrand, where two brothers changed how the world moves.
135 years later, let's see how they do it. Before Michelin can build a tire, they must gather the Earth's resources. It begins in the tropics. Natural rubber, latex from the hevea tree, tapped by hand, just as it was a century ago. Each tree yields just 30 grams per day. For one tire, you need hundreds of trees. The latex is coagulated, rolled into sheets, and dried. Raw rubber. Humble. 30% of a modern tire is natural rubber. The rest? That's where science begins. Synthetic rubber. Engineered molecule by molecule. Each type designed for a specific purpose. Styrene butadiene rubber for grip. Polybutadiene for flexibility. The right blend changes everything.
Carbon black. It gives tires their color and their strength. Pure black. Pure power.
Microscopic particles. Each one bonds with rubber at the molecular level. Silica. It reduces rolling resistance, better fuel economy, fewer emissions, innovation meeting responsibility. Steel. High tensile wire. Each strand capable of resisting 33 pounds of force. Polyester. Nylon. Kevlar. Fabrics that will bear the weight of empires. Sulfur for vulcanization. Zinc oxide to activate. Accelerators to control. A pharmacy of transformation. Every raw material is tested. Michelin rejects anything less than perfect. 200 components. Every one accounted for. Every one essential. The ingredients are gathered. Now, the transformation begins. The mixing hall, where Michelin's secrets take physical form. The Banbury mixer, a beast that devours raw materials and creates magic. Each tire requires different compounds. The tread formula, the sidewall formula, the inner liner, all different, all secret.
Every gram matters. A fraction too much or too little, and the tire fails.
Natural rubber, synthetic rubber, carbon black. Into the mixer they go. Then the rams descend. Massive pressure, enormous heat. The mixing begins.
Inside, counter-rotating rotors shear the rubber. Temperature rises to over 100 degrees Celsius. Too hot, and it vulcanizes prematurely. Every batch balanced on a razor's edge. When the moment is right, the batch drops.
The drop mill continues the work. Kneading, refining, building consistency. The rubber emerges as a sheet, still hot, still transforming. An anti-tack solution prevents the rubber from sticking to itself. Chemistry at every step. A sample from every batch is tested. Tensile strength, viscosity, elasticity. The formula must be perfect.
The festoon. Hundreds of meters of cooling. The rubber must reach ambient temperature. Approved batches move to storage. 16 different compounds, each waiting for its purpose.
Tread compound for grip, sidewall compound for flexibility, inner liner for air retention. Different jobs, different formulas.
The Calendering Hall, where rubber meets reinforcement, where strength is born. Textile cords, polyester, nylon. Each strand will bear enormous loads. The 4-roll calendar, counter-rotating rollers that squeeze rubber around every fiber. Hot rubber is fed from the mills. Temperature and consistency are critical. The rubber is squeezed around every fiber, insulating them, bonding with them, making them one. Calendered ply emerges. Rubber and fabric, now inseparable. Automatic thickness control. Deviation measured in fractions of a millimeter. The inner liner is different. Halo-butyl rubber, designed to hold air for years. Cut to precise specifications. Width, length, angle, every cut calculated. The bias angle, critical for tire flexibility and strength. Each ply is rolled with a liner, waiting for assembly. Body plies, belt plies, reinforcement layers, each with its purpose. Adhesion is tested, thickness verified. Any flaw is rejected. The skeleton of the tire is ready. Now we need its armor. Steel, the armor beneath the tread. High-tensile steel wire. Each strand can resist 33 pounds of force, thousands of strands in every tire. The wires are guided with surgical precision. Any misalignment weakens the belt.
Rubber is extruded around each wire. Steel and rubber becoming one.
Coated steel cord, the most critical structural element of any high-performance tire. The steel calendar operates under even higher pressure, creating sheets of steel-reinforced rubber.
Spacing must be perfect. Every cord parallel. Every gap identical.
Cut at calculated angles. These belts will stabilize the tire at speeds over 300 miles per hour.
Multiple layers, alternating angles, This creates the stability that makes high-speed driving possible. Temperature and humidity are strictly controlled. Any rust would compromise the bond. Every batch is tested to destruction. Michelin must know exactly when it fails.
The extrusion hall, where rubber is given form.
The armor is forged. Now the tread.
The quadruplex extruder, 4 compounds, 4 screws, 1 continuous tread.
Base compound, core compound, tread compound, wing compound, each with its role. The screw pushes the rubber forward, shearing, heating, preparing for the die. The die, a precision machine profile that gives the tread its shape. The tread emerges, multiple compounds perfectly layered, the contact patch with the road. Cooling must be precise. Too fast, it cracks. Too slow, it deforms. Cut to exact length, each size, each specification, perfect every time. Sidewall compound is different, designed for flexibility, for absorbing impacts, for protecting. The sidewall will carry the tire's identity, size, speed rating, the Michelin name. Treads, sidewalls, fillers. The extrusion hall never stops.
Temperature must stay below 110 degrees Celsius. Any hotter and it scorches.
Every component is measured. Dimension, weight, profile. No deviation accepted.
The bead. It locks the tire to the wheel. Fail here, and the tire leaves the rim. Copper-plated steel wire, coated with rubber, strong enough to resist thousands of pounds of pressure. The wire is wound into a perfect circle. Multiple wraps. Exact diameter. Layer upon layer. The more wraps, the stronger the anchor. The bead filler is attached. It stiffens the bead area. Controls the tire's feel. A complete bead. Simple in appearance. Critical in function. Diameter is verified to hundredths of a millimeter. The bead must fit the wheel perfectly.
2 beads per tire, 1 for each side, each one critical.
The anchors are ready. Now we build a tire.
Every component converges. 200 parts. One purpose.
The tire building hall. The most difficult step in the entire process.
The tire building machine, where every component must come together perfectly. Tire building requires years of training. These operators can feel a fraction of a millimeter with their fingertips. First, the inner liner, the airtight seal, the tire's lungs. No air bubbles. Any trapped air becomes a weakness. Body ply, the tire's structural foundation. The beads are placed exactly where the tire meets the wheel. The ply turns up around the beads, locking them into the tire structure forever. Sidewalls are added. Protection against curbs, against impacts, against time. First stage complete. The carcass. The tire's skeleton. Now, the belts and tread, where grip and stability are born. Steel belts at alternating angles. The armor that keeps the tread flat at any speed. Finally, the tread. The tire's face to the world. Its grip on reality. Air pressure brings the components together. The tire's shape begins to emerge. The green tire. Uncured, unfinished, but unmistakably a tire.
Ready for the transformation. Ready to become eternal. The Curing Hall, where rubber becomes eternal.
The tire curing press. Temperature, pressure, time, all precisely controlled. The mold contains the tire's final identity. Every tread groove, every letter, the Michelin name itself. The green tire enters the press. It will emerge, transformed.
22 bar of pressure. Over 300 pounds per square inch.
Inside, a bladder inflates with steam, pressing the rubber into every detail of the mold. 160 degrees Celsius, hot enough to trigger the chemical transformation. Sulfur creates crosslinks between rubber molecules, turning soft rubber into something that can last decades.
10 to 15 minutes. The exact time depends on the tire. Too long or too short, and it fails. Across the hall, thousands of tires are being transformed simultaneously. The press opens. Steam rises. And inside is a tire. Real, permanent, ready for the world. Still hot from the press. Every detail perfect. Every surface transformed. Now it must cool. And then, the real test begins.
Quality control. Every single tire is inspected. No exceptions.
First, human eyes. Trained to spot imperfections invisible to machines.
Every surface, every groove, every letter, nothing escapes scrutiny. The uniformity machine. It measures variations too small for humans to feel. Force variation, radial runout, lateral runout, any excess, and the tire is rejected. X-ray reveals what eyes cannot see. Steel belt alignment, air pockets, internal anomalies.
The tire's skeleton exposed. Every flaw visible. Every weakness found.
Chirography. Detecting air bubbles smaller than a grain of sand. Balance testing. Even weight distribution ensures smooth rotation at any speed. Minor defects are marked. Major defects, the tire is destroyed. Rejected tires are never sold. Michelin's name means perfection or nothing.
Every data point is analyzed, looking for trends, preventing problems before they happen.
Random tires are sacrificed, cut open, analyzed, confirming the process works. Every layer visible, every bond confirmed. 200 components, perfectly integrated.
Approved. The Michelin seal of quality. Ready for the world. From the factory floor to roads around the world. But some tires have a different destination.
Ladoux, Michelin's most advanced technology center, where the impossible becomes routine.
For over 20 years, Michelin has partnered with Bugatti, creating tires for the fastest cars on Earth.
An elite team. Engineers who design tires for speeds most humans will never experience.
The Pilot Sport Cup 2, designed for the Bugatti Chiron, for speeds over 300 miles per hour. Carbon fiber reinforcement, the same material used in fighter jets, in a tire.
At 300 miles per hour, the tires experience 5,300 grams, enough to tear apart ordinary rubber.
To test these tires, Michelin uses a machine designed for the space shuttle. It can simulate 510 kilometers per hour. The tires are pushed to their absolute limits, again and again, until Michelin is certain.
Every hypercar tire is X-rayed individually, not random samples. Every single one.
The BG mark. This tire is certified exclusively for Bugatti. Handled with white gloves. These tires cost more than most cars. Bugatti, Koenigsegg, Ferrari. When speed matters most, they call Michelin.
August 2019. 304.77 miles per hour. The fastest street-legal tire ever.
Shipped directly to Molsheim,
To Engelholm.
where the world's most expensive cars await them. Millions of tires, each one a journey of transformation, each one waiting to carry someone forward. From Clermont-Ferrand to every corner of the earth. 170 countries. Most will go to ordinary cars, carrying families, making memories, arriving safely. Some will go to Molsheim, to become part of $3 million machines. 4 contact patches, each the size of your palm, connecting 1,600 horsepower to the earth.
300 miles per hour, and the tire holds. The transformation holds. Michelin holds.
Remember where it started? A pile of rubber. And now, this. The same atoms, transformed by human ingenuity. 132,000 people, building something that matters, something that saves lives. Bibendum, 55 years old, still smiling, still representing quality.
Clermont-Ferrand, where two brothers changed how the world moves.
From raw rubber to this, from dirt to world records. 200 components.